Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Diploma Programme, Postgraduate Diploma in Computer Applications, PGDCA, New, Semester 2, MCSL, to 10 DBMS and Java Lab, Section-1 DBMS Lab, 1.0 Introduction, Information Technology, IT. Has influenced organizational performance and competitive standing. The increasing processing power and sophistication of analytical tools and techniques require a strong foundation of structured form of data. Thus, the presence of a commercial, secure, reliable database management system is a major requirement for businesses. You must have obtained the practical skills of several programming languages by now. However, when you want to create a secure, managed database application, you need not restart from scratch and develop a huge system using a programming language. Rather, you can use a database management system. This software allows us to create databases, queries, and many more operations on data. This section is an attempt to familiarize you with commercial database management features so that you are able to apply some of the important features of DBMS in a commercial situation. This would require a sound background of the concepts of DBMS, which can be acquired through the course MCS 207 Database Management Systems. You would also have to apply the conceptual background to obtain problem-solving skills using a commercial RDBMS. The topics that have been included in this section are SQL commands for various types of operations. Please note that we have given many examples in this lab section in different sessions, highlighting the basic syntax of various statements. However, they are not exhaustive, as commercial RDBMSs implement a large number of statements and functions. Therefore, you must refer to the user reference manuals of the commercial RDBMS for more details on these topics. Also, we have given examples for a typical RDBMS. However, you may do practical on any commercial RDBMS supporting such concepts. However, you should find the changes in the statements used here for the RDBMS you may be using. Remember, the objectives of this section, consisting of 10 sessions, will be completed only if you practice using any commercial RDBMS. You are also advised to run all the example queries too. However, you may find that some of these queries may run on the RDBMS selected by you. In such cases, you are advised to modify the query as per your RDBMS 1.1 objectives. After going through this section and performing all the practical exercises, you should be able to write and run SQL queries for table creation, create integrity and constraints on databases, write and run SQL queries, create and run subqueries, views, indexes and procedures, write simple embedded SQL-related programs, manage transactions using SQL, write simple triggers, and perform simple user management. 1.2 Database creation, data modification and simple queries, objectives. At the end of this section, you should be able to use SQL to create a database with constraints, insert data in a table, perform simple queries. This section deals with the process of database creation, insertion of data in the database, altering the database design, data modification and writing simple queries. 1.2.1 Database creation and inserting data into the database. For database creation, you need to use the create command. For this, first, you need to create a database using the command create database name. This is followed by the command use database name. You can now create tables in the database. The following command allows you to create a table. Create table name, column underscore name 1 data type, column width, constraints, column underscore name to data type, column width, constraints, where table name assigns the name of the table, column name defines the name of the field, data type, specifies the data type for the field, and column width allocates specified size to the field. Guidelines for creation of table. Times table name should start with an alphabet. Times in table name, blank spaces and single quotes are not allowed. Times reserve words of that DBMS cannot be used as table names. Times proper data types and sizes should be specified. Times unique column name should be specified. Column constraints. Some of the important constraints are not null, unique, primary key, check, default, references, on delete, restrict, etc. Example 1. The command to create a table named product, PNO, name, quantity, having the primary key, PNO, which ensures that product number, PNO, is not null and unique. Both are the properties of primary key. The product name, should not be left blank. The table has a constraint that the quantity should be between 1000 and 4500. This table can be created using the following SQL command: create table product, PNO number 4, primary key. Name char 20, not null. Koh number 5, check, Koh 1000 and Koh 21 years, address, gender, male, M, or female, F, or not, salary, range of 500 to 25,000, date of joining, department number refers to department number of department table, department name, not null unique, department number, primary key, manager underscore ID refers to employee ID of employee table. Manager date of joining, not null, department location, department number refers to department number of department table, department location, not null, department number and department location are combined. Primary key, project name. Not null, project number, primary key, project location, not null. Department number refers to department number of department table, works on, employee ID, not null refers to employee ID of employee table, project number, not null refers to project number of project table, hours, not null, employee ID, project number are combined. Primary key, dependent, employee ID refer to employee table, employee ID field, dependent name, gender, M or F, date of birth, not null, relationship, not null. Now enter a few sets of meaningful data and answer the following queries. 1. List the department-wise details of all the employees. 2. Find all those departments that are located in more than one location. 3. Find the list of projects. 4. Find the list of employees working on a project. 5. List the dependents of the employee whose employee ID is 001. Question 2. Develop a prototype database of the IGNOU library management system and create the following tables. A. Book records. B. Book details. C. Member details and D. Book issue details. The structure of the tables is given below. Table name, attribute name, book records, accession number, ISBN number, books ISBN number, author, publisher, price. Members, member ID, member name, maximum number of books that can be issued to a member. Maximum number of days for which book can be issued, book issue member ID, accession number, issue date, return date. You must create constraints, including referential integrity constraints, as appropriate. Please note, accession number is unique for each book. A book which has no return date can be considered as the issued book. Enter suitable data into the tables. Now answer the following using SQL. 1. Insert data in all three tables. Use insert. 2. Insert appropriate description associated with each table and the column. Use comment. 3. Display the structure of the tables. 4. Write the queries for performing the following function in SQL. A. Get the list of all books, no need to find the number of copies. B. Get the list of all members. C. Get the accession number of the books that are available in the library. D. On the return of a book by a member, calculate the fine on that book. E. List of books issued on 1st January 2021. F. Get the list of all books having prices greater than 500 rupees. G. Get the list of members who did not have any book issued at any time. H. Get the list of members who have not returned the book. I. Display member ID and the list of books that have been issued to him/her from time to time. J. Find the number of copies of each book. A book accession number would be different, but ISBN number would be the same. K. Find the number of copies available of a book of the given ISBN number. L. Get the member ID and name of the members to whom no more books can be issued, as they have already got as many books issued as the number for which they are entitled. Question 3. For the library management system you created in question 2 above, answer the following queries. 1. Get the list of ISBN number, book names and number of available copies of those books whose number of available copies is at least 1. This list should be in ascending order of book name. 2. Get the list of ISBN number, book name, author, total copies, cost is price total copies, in descending order of cost. 3. Get the list of books issued to each member. 4. Write a query to know the maximum and average price of the books. 5. Get the list of all existing members and the number of days for which a member is allowed to keep the book. Also, find out the members who have got the maximum number of books issued. 6. Get the list of member codes of those members who have more than 2 books issued. 7. Find the details of the books presently issued to a member. Question 4. Create the following table named customer, column name type size, customer-id character 10, name character 25, area character 3, phone numeric 7. Insert the appropriate data into the table and perform the following operations. Times update phone numbers of all customers with prefix as your city STD code. Times print the entire customer table. Times list the names of those customers who have E as the second letter in their names. Times find out the customer belonging to area ABC. Times delete record where the area is null. Times display all records in increasing order of name. Times create a table temp from the customer having customer-id, name and area. Times display area and the number of records within each area. Use group by clause. Times display all those records from the customer table where name starts with A or area is ABC. Times display all records of those where the name starts with A and phone exchange is 55. Times add one attribute named mobile in the table and copy phone numbers into it. Question 5. Create the following tables. Set all the referential constraints among the tables. Insert about 10 records in each relation. You may assume a suitable data type and length for each attribute. Primary key of each relation is shown with an underline. Please also note that there is no overlap of limits for a grade in the pay scale relation. Teacher, T_no, F_name, L_name, salary, supervisor, joining date, birth date, job title, class _no, T_no, room_no, pay scale, min_limit, max_limit, grade. Please note that T_no in the class relation references T_no in the teacher relation and supervisor one of the teacher. 1.3 Subqueries and joins, objectives. At the end of this section, you should be able to define subqueries and joins. Create different types of subqueries. Perform different types of join queries. The queries are given in this session and most of the later sessions are based on the teacher. Class and pay scale relations that you have created in question 5 of the section 1.2.3 and are given below: teacher, T_no, F_name, L_name, salary, supervisor, joining date, birth date, job title, class, class_no, T_no, room_no, pay scale, min_limit, max_limit, grade. Please note that T_no in the class relation references T_no in the teacher relation and supervisor one of the teacher. 1.3.1 Subqueries. Subquery means a select statement that retrieves the values from the table and passes these values as an argument to the main or calling select statement. In simple words, nested queries are subqueries. Subqueries can be of different types: 1. Single row subquery, 2. Multiple row subquery, 3. Multiple column subquery, 4. Correlated subquery. Single row subquery. Single row subquery is the query that returns only one value or row to the calling select statement. For example, query 1, display the name of the teacher who is the oldest among all teachers. Explanation: to know the name of the teacher who is the oldest, you need to first find the minimum birth date and then, corresponding to that date, display the name of the teacher. Assume that only one teacher is the eldest. Select F_name, L_name from teacher, where birth date is equal to, select min, birth date, from teacher. Query 2, display teacher number and name of those teachers who are earning less than a teacher is equal to greater than equal to the subquery match the condition. 40, to remove a view, drop statement is used. For example, drop view teacher_details. 1.4.2 Indexes. Index is an object that reduces the record retrieval time. An index contains a row pointer, which determines the location of the record and the values of the target columns. Indexes can be based on one or more table columns. Two types of indexes can be created. 1. Unique indexes. These indexes are created automatically whenever a primary key or unique constraint is defined. 2. Non-unique indexes. These indexes are created explicitly by the user on non-unique keys. Syntax: create index index_name on table name, column 1. Column 2. Example 2. Create an index on the relation teacher on the job title. For fast access, create index T_title_index on teacher, job title. To remove an index, drop statement is used. For example, drop index T_title_index. 1.4.3 Exercises for Session 7. Question 1. Please attempt the following problems for the teacher, class and pay scale relations given in Section 1.2.3. These relations are shown below: teacher, T_no, F_name, L_name, salary, supervisor, joining date, birth date, job title, class, class_no, T_no, room_no, pay scale, min_limit, max_limit, grade. A. Create a view named supervisor_details that stores the names and numbers of all the supervisors. B. Create a non-unique index on the foreign key column of the class table. C. Modify the view created in A and add details like salary, job title, joining date, birth date, etc. of all supervisors. T. Using the view created in C, display details of all supervisors who have worked for more than 15 years. E. Create a view that stores the details of all the teachers who are TGT and earning more than 12,000 rupees. F. Drop the view created in E. G. Create a non-unique index on the names of teachers in the teachers table. H. Drop the index created in B. I. Create a view named teacher_info that allows users to only view the teacher ID, name, salary, and grade of the teachers. It should not allow any user to change, update any information. J. Create a view that displays details of all teachers who are in grade B and are more than 40 years old. Question 2. Design suitable views on the Open University database system designed by you, as per Question 4. Section 1.3.3. Practical exercises for Session 4 to Session 6. For example, you can create a view for the faculty giving him/her details of his/her students. Create at least 5 suitable queries on each of the views created by you. Also, create indexes for the university database system. For example, you can create an index on the student name, thus allowing faster access to student information in the order of student names. You must explain how the indexes created by you would enhance the performance of the database system. Implement the above in a commercial DBMS using SQL. Question 3. Design suitable views and indexes for the bank database system designed by you, as per Question 5. Section 1.3.3. Practical exercises for Session 4 to Session 6. Create at least 5 suitable queries on each of the views. Explain how the indexes created by you would enhance the performance of the database system. Implement the above in a commercial DBMS using SQL. 1.5 Control loops and procedures. Objectives. At the end of this session, you should be able to use procedural constructs like loop define and use for loop. While loop define and use procedures, you can use the programming language supported by your DBMS. In this section, examples are shown using PL/SQL. PL/SQL extends SQL by adding control loops found in procedural languages, resulting in a structural language that is more powerful than SQL. We will introduce the use of PL/SQL in this session with the help of examples. 1.5.1 Control loops. Loops are the constructs that help to repeat the statement groups on certain conditions. Let us discuss the two basic looping constructs: for, while, for loops. For loops are the common loops. For loop uses a loop variable. You define the initial value, the upper bound, increment of loop variable in the for loop. Example 4. Using for loop for a counter from 1 to 100, declare a number is equal to 1. They can be invoked or called by any PL/SQL block. The syntax is create or replace procedure name, argument, inout, data type, .is, variables declarations, begin, PL/SQL subprogram body, exception PL/SQL block, and procedure name, replace. If procedure is already created, then replace it. In indicates that the parameter will accept a value from the user. Out indicates that the parameter will return a value to the user. Inout indicates that the parameter will either accept from or return a value to the user. Example 7. Following procedure searches the name of a teacher in the relation teacher. Create or replace procedure search _teacher, O_T_no in number. O_F_ name out varchar2, O_L_ name out varchar2, is, begin, select F_ name, L_ name into O_F_ name, O_L_ name, from teacher, where T_no is equal to O_T_no, and search _teacher, run. It is used to create the procedure. To call this procedure, declare O_F_ name teacher.F_ name %type, O_L_ name teacher.L_ name %type, begin, search _teacher, 113, O_F_ name, O_L_ name, DBMS_output.put_ line, employee, 113, DBMS_output.put_ line, name, vertical bar O_F_ name, vertical bar O_L_ name, and example 8, 2. Demonstrate use of inout parameter, create procedure bonus_calc, O underscore T underscore no in integer, bonus in out integer, is, join underscore date, begin, select salary 0.20, joining date into bonus, join underscore date, from teacher. Where T underscore no is equal to O underscore T underscore no, if months underscore between, sysdate, join underscore date, 36 then, bonus, is equal to bonus 1000 and if, and, important notes, 1, unlike the type specifier in APL SQL variable declaration, the type specifier in a parameter declaration must be unconstrained, i.e. char or varchar 2 should be used, instead of char 5, or varchar 2, 20.2. The name of the procedure after the end is optional. 3. A constant or a literal argument should not be passed in for an out-in-out parameter. 1.5.3. Exercises for Session 8. Question 1. Please perform the following using the following relations: teacher, T underscore no, F underscore name, L underscore name, salary, supervisor, joining date, birth date, job title, class, class underscore no. T underscore no, room underscore no, pay scale, min underscore limit, max underscore limit, grade, A. Calculate the bonus amount to be given to a teacher depending on the following conditions. I. If salary 10,000 then bonus is 10% of the salary. 2. If salary is between 10,000 and 20,000 then bonus is 20% of the salary. 3. If salary is between 20,000 and 25,000 then bonus is 25% of the salary. 4. If salary exceeds 25,000 then bonus is 30% of the salary. B. Using a simple loop structure, list the first 10 records of the teachers table. C. Create a procedure that selects all teachers who get a salary of 20,000 rupees and if less than 5 teachers are getting 20,000 rupees, then give an increment of 5%. D. Create a procedure that finds whether a teacher number whose information is requested by a user exists or not. In case the teacher information does not exist, then display no such teacher. E. Using for loop, display the name and teacher number of all those teachers who are more than 58 years old. F. Using while loop, display details of all those teachers who are in grade A. G. Create a procedure that displays the names of all those teachers whose supervisor is teacher named Suman. H. Calculate the tax to be paid by all the teachers depending on the following conditions. I. If annual salary 5 lakhs then no tax. 2. If annual salary is between 5 lakhs and 1 and 15 lakhs then tax is 20% of the annual salary. 3. If annual salary is between 15 lakhs and 1 and 25,000,000 then tax is 30% of the annual salary. 4. If salary exceeds 25 lakhs then tax is 40% of the annual salary. I. Create a procedure that finds the name of all the teachers with the job title PRT and if the number of teachers returned is more than 10 then change the job title to TGT for the top 3 PRT teachers based on their hire date. Question 2. Identify the need for procedures for the university database system. For example, you can create a procedure that awards 2% grace marks for those students who have got 48% marks. Design at least 5 such procedures. Implement these procedures using embedded SQL. Question 3. Implement at least 5 procedures for the bank database system using embedded SQL. 1.6 Transaction Management, Triggers and Functions, Objectives. At the end of this session, you should be able to use commit, rollback and save point specifications. Define triggers and functions. Define and create statement and row triggers. Create functions with or without parameters. 1.6.1 Transaction Management. A transaction is a logical unit of work that is composed of one or more statements of data manipulation language DML, or Data Definition Language, DDL, or Data Control Language, DCL. A transaction starts when an SQL statement is executed and terminates when any of the following occurs: any DDL or DML statement is executed. A commit or rollback statement is given. User exits SQL. The transactions can be committed implicitly or explicitly. All DDL or DCL statements are implicitly committed. There are three explicit transaction specifications. 1. Commit. It ends the current transaction and saves all pending changes permanently since last saved, or commit or rollback. The syntax is commit. 2. Save point. It marks and saves the current point of the transaction process. It is useful for performing partial rollbacks. The syntax is save point name. 3. Rollback. It ends the transaction but discards all pending changes since the last commit, point or save point. The syntax is rollback to save point name. Example: SQL update teacher set job title is equal to PGT where salary 15,000. SQL commit. Changes made by update statement are saved. SQL insert into class _no, t_no, room_no, values 10,127,226. SQL rollback. Values inserted into class table are discarded. SQL update teacher set job title is equal to supervisor where salary 20,000. SQL save point update _done. Save point created. SQL delete from teacher. SQL rollback to save point update _done. Just delete statement is discarded. 1.6.2 triggers. For the following discussion, we will consider the following relations: teacher, T_no, F_name, L_name, salary, supervisor, joining date, birth date, job title, class _no, T_no, room_no, pay scale, min_limit, max_limit, grade. A trigger is a block of code stored in the database. It is executed on the occurrence of an event in a database table, e.g. insertion of a record in a table. Triggers are implicitly invoked by DML, commands like insert, update or delete. But you cannot use commit, rollback and save point statements within trigger blocks. Triggers can be called before or after the events. Triggers can be of two types. 1. Statement type. Statement triggers fire before or after the execution of the statement that caused the trigger to fire. 2. Row type. Row triggers fire before or after any affected row is processed. Example 1. The following is a statement trigger which does not allow working on the database. During weekends, create or replace trigger not _working_r before delete or insert or update on teacher. Begin if to_char sysdate dy in SAT sun then DBMS_output.put line. Sorry. You cannot delete update insert on weekends. And if and example 2, a row trigger for supplying new teacher ID and system date as the joining date. Create or replace trigger new_teacher_ID after insert on teacher. For each row, declare o_t_no teacher.t_no %type o_joining date teacher.joining date %sign type. Begin. Select t_no sequence.next will into o_t_no from dual new.t_no is equal to o_t_no new.joining date is equal to sysdate and 1.6.3 functions. Functions are similar to procedures but in function definitions you must explicitly return a value to the calling block via the return statement. A function can have 0, 1 or more parameters. Example 3. Find the grade of a teacher. 1 parameter function. Create or replace function get_grade o_t_no in number is o_grade varchar 2 20. Begin. select grade into O_grade from pay scale, teacher, where T_no is equal to O_T_no and salary between min_limit and max_limit. Return O_grade and get_grade. This function can be called from block of code as O_teacher_grade is equal to get_grade, O_teacher_no. Example 4. Function without parameter. Create or replace function welcome_note return varchar2 is begin, return good morning and welcome_note. This function can be called from a block of code as a is equal to welcome_note DBMS_output. But line a to drop a function, drop function. 1.6.4 Exercises for Session 9. 1. Write an embedded SQL block to select the name of the teacher with a given salary. If more than one row is returned, then display all the retrieved rows. If no row is returned, then display no teacher with this salary. 2. Write a program that displays the details of all those teachers who have reached the maximum limit of their grades. If no row is retrieved, then display no teacher reached the max limit of grade. 3. Insert at least 5 new rows in the teacher table and then try to roll back the last 3 rows inserted to the table. 4. Write a program that displays the names of all teachers who will attain the age of 60 years in the current year. If no row is retrieved, then display a suitable message. 5. Write a code block that displays all the rows from teacher table if the teacher was hired for more than 10 years and still is a PRT. If there is no result, then display a suitable message. 6. Experiment with DDL and DML commands along with commit and rollback for the teacher, university and banking databases. 7. Write a trigger that is fired before the DML statement's execution on the teacher table. The trigger checks the school timings based on sysdate. Beyond the school working hours, the trigger does not allow any work to be performed on the data. 8. Write a trigger that is fired before an update statement is executed for the teacher table. The trigger should write the name of the teacher, username and system date in an already created table called update_table. 9. Write a function and pass a job title to it. If the teacher table does not contain any row corresponding to that job title, then return false, otherwise true. 10. Write a trigger that verifies the joining date when a new row is inserted in the teacher table. The joining date should be greater or equal to the current date. 11. Write a function that gets the teacher number as a parameter and returns the class number associated with that teacher. If the teacher is not a class teacher, then it outputs a suitable message. 12. Write a function and pass a teacher number to it. If the teacher table does not contain that teacher number, then return false, otherwise true. 13. Write a function that takes the teacher number as a parameter and returns the name and joining date of the teacher. 14. Write appropriate triggers and functions for the university and bank database systems. 1.7 User Management and Object Privileges. Objectives. At the end of this session, you should be able to define and create user accounts, define the types of privileges, give and withdraw the privileges. 1.7.1 User Management. Before the database is used by several users, they should be given privileges on their user groups. By default, Oracle has two accounts, sys and system. The system account is used to give privileges to the users and to create new user accounts. The user account can be created by the create user command. Example 1. Create a user account manager with password pass. Create user manager identified by pass. These user accounts are of use when the privileges are given to them. There are two types of privileges. 1. System privilege. This kind of privilege allows a user to use DDL commands like create, table, drop index, etc. 2. Object privilege. This kind of privilege allows a user to use DML commands like update, insert, etc. We use grant and revoke commands to give and take back the privileges to user accounts, respectively. Example 2. Give, create and drop privileges related to table view to the user account manager. Grant, create table, drop table, create view, drop view to manager. Example 3. Withdraw, drop privilege related to table view given to the user account manager. Revoke, drop table, drop view from manager. 1.7.2 Exercises for Session 10. 1. Create a user account class and give privileges related to table view creation, deletion, updating and dropping. 2. Create a student account and give permission to this account for only viewing the information on the relation class, class_no, t_no, room_no. 3. Create at least 3 to 4 different types of users for each of the database systems: Viz, University and Bank. Design suitable access privileges for the users. Grant these permissions to the users. 4. Consider when you have a large number of students and teachers in the university databases that have different access rights. Is there any mechanism in DBMS that allows defining an account type to some specific role? If yes, then define such types for the university database system. 5. Define different types of users for the bank database and provide them with suitable access rights. 6. Practice different SQL commands on various databases you have developed. 1.8 Summary. This section has broadly covered different aspects of a commercial DBMS. Some of the topics covered during the practical sessions include database creation with constraints, database queries, subqueries and join-based queries, creating views, indexes, operations using commit and rollback, commands used in transactions, triggers and functions, and user management. You should try to solve not only the problems given in these exercises, but also many other problems during your practical sessions. You should consult online help reference manuals of the commercial RDBMS you are using while solving the problems. Practice is the key to achieving the basic objectives of the sessions. Finally, please keep in mind that the basic objective of this section is not to make you an expert DBA but will introduce you to different types of SQL commands that you can perform using a DBMS. You should look forward to applying your theoretical knowledge of MCS 207 along with the skills obtained during the practical sessions to create solutions with respect to the data needs of various business organizations. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.